Last class, we have seen what is an autonomous system and what do we mean by the critical point of an autonomous system. So, in today's class, we will look at few definitions, and using these definitions, we will actually classify the critical points into four main types. So, we'll be looking at the classification of critical points, and this classification will give you what are the possible types of possible behavior of the solution around the critical points. So we have this autonomous system which is of the form dx by dt equal to f of xy and dy by dt equal to g of xy. So we are calling this as equation 1. Now f and g continuous functions, and they have continuous first order partial derivatives. So these are the conditions, or that is how we define an autonomous system. Now the critical points are given by so they are the points which satisfy the simultaneous conditions f equal to 0 and g equal to 0. Now let us look at two definitions which will help us in classifying the critical points. Now, the first definition is, when do you say that a path approaches to a point x0, y0, and when does a path enter a point x0, y0? So, let x0, y0 be a critical point of your autonomous system. So we have f equal to 0 and g equal to 0. So when you apply the conditions, we get the critical point and x0, y0. So x0, y0 is an isolated critical point, and let c be the path which is traced by the solution curve x equal to x of t and y equal to y of t. നമ്മുടെ path എന്താണെന്ന് കണ്ടു last class. So your solution of the autonomous system will be curve of the form x equal to x of t, y equal to y of t. So as t increases, we will be getting a directed curve as a solution. So that is called the path. Now we say that c approaches x0, y0 as t tends to infinity if limit t tends to infinity x of t is equal to x0 and limit t tends to infinity y of t equal to y0. So that is our first definition. So if limit t tends to infinity, x of t is equal to x0, and if limit t tends to infinity, y of t is equal to y0, we say that c approaches to x0, y0 as t tends to infinity. Now the second definition is when c enters a critical point. So for that, so that is the second definition, c enters a critical point x0, y0. So we consider the limit t tends to infinity, y of t minus y0 by x of t minus x0. This actually measures the slope. So you have y minus y0 by x minus x0. So this is the slope of the line which joins the points x0, y0. So if you have the points x0, y0 and the point xy, then the slope of the line which joins these 2 points, that will be equal to this ratio. Now take limit t tends to infinity, y of t minus y0 and x of t minus x0. Now this limit exists, or if the limit is either plus infinity or minus infinity, as t tends to infinity, we say that c enters the critical point x0, y0 as t approaches to infinity. So this limit exists, or it is either plus infinity or minus infinity. Provided this happens, then we can say that c enters the critical point x0, y0. So those are the two definitions. So if limit t tends to infinity, x of t equal to x0, and limit t tends to infinity, y of t equal to y naught, then we say that the path will approach the point x naught y naught as t tends to infinity, and if the limit y minus y naught by x minus x naught provided it exists or it is plus or minus infinity, as t approaches to infinity, then we say that c enters the point x naught y naught. So using these two definitions, we will be classifying our critical points. When you classify the critical points, first we'll do two types of class. We'll analyze the classification in two ways. ഫസ്റ്റ് നമ്മൾ ചെയ്യുന്നത് ഈ പാത്ത് എങ്ങനെയാണ്, പാത്തിൻ്റെ ബിഹേവിയർ എങ്ങനെയാണ്. അപ്പോൾ പാത്ത് നമ്മളിപ്പോൾ കണ്ടു, പാത്ത് അപ്രോച്ച് ചെയ്യാം ക്രിട്ടിക്കൽ പോയിന്റിനെ, ക്രിട്ടിക്കൽ പോയിന്റിൽ കൂടെ പാസ് ചെയ്യണമെന്നില്ല, അപ്രോച്ച് ചെയ്യുന്ന പോലെ ആയിരിക്കാം പാത്ത്, അല്ലെങ്കിൽ ചിലപ്പോൾ പാത്ത് ക്രിട്ടിക്കൽ പോയിന്റിൽ കൂടി പാസ് ചെയ്യുന്ന പോലെ ആയിരിക്കാം. സോ യൂസിങ് the behavior of the path near your critical points, will make a classification of critical points. അപ്പോൾ നമ്മൾ ആ കേസിൽ അതിൻ്റെ പാത്ത് എങ്ങനെയാണെന്ന് അറിഞ്ഞിരിക്കണം. So for that we need to know what is x equal to x of t and y equal to y of t. ഇനി നമുക്ക് എപ്പോഴും ഓട്ടോണമസ് ഇക്വേഷൻസ്, ഓട്ടോണമസ് സിസ്റ്റം എക്സ്പ്ലിസിറ്റ്ലി സോൾവ് ചെയ്യാൻ പറ്റണം നിർബന്ധമാണ്. need not be able to find the solution in the form x equal to x of t, y equal to y of t. So if that is there, we can look for the behavior of your critical points. So if you have x equal to x of t, y equal to y of t, so we have the directed paths in those cases, so we can look for the behavior in that case. Now if that is not so, if you cannot find x equal to x of t and y equal to y of t, then we can eliminate t from the equation. So we have the equations dy by dt equal to g and dx by dt equal to f of xy. So this would give us, by eliminating dt, we will get dy by dx equal to g of xy by f of xy. So we can see that this is the first order differential equation. So by solving this differential equation, we will get a solution which involves x and y. So we will be getting a one parameter family of curves. So we will be getting the solution as a one parameter family of curves. Now this one parameter family will give us different curves. So using these curves, we can now study about the behavior of the autonomous system around your critical points. ഇനി നമ്മൾ ഫസ്റ്റ് കേസിൽ നമുക്ക് x equal to x of t, y equal to y of t. So your solution will be in this form. If you are taking this one parameter family of curves, so we will get solution something in the form f of xy equal to c. So the difference between these two set of solutions is, so here we will be getting directed paths in this case. Now here the curves you get here, they are undirected, so these do not have any specific direction. So here you can look for what happens when t approaches to infinity or t goes to minus infinity. So we will be getting directed paths here, and here the paths you are getting will be undirected. So that is the difference when you deal with two kinds of solutions. So this does not have a direction associated with it. Still you can get an idea of what type of paths you are getting. Okay, and now let us move on to the classification of the critical points. Now for our convenience, here we will be looking at examples where the critical point is the origin. So we will see the four main types of critical points. So we will assume that the critical point under discussion is the origin. So the first type of critical point is called a node. Now you can see this graph. So in the graph we have the origin. So you can see that there are directed paths ഇനി നമുക്ക് കാണാൻ പറ്റും all the paths. So we have the lines. So let me call this point to be O, that is the origin. So we have the half lines AO. AO is approaching the origin. Then you have the half line BO. BO is approaching the origin. Then there is a half line CO, which is approaching origin. Then there are half lines, half line BO, which is approaching the origin. So when we take the line AB, that enters origin. So when you take the line CD, that will be entering the origin. And then the rest of the paths are parabolas, which enters the origin. So we can see that all the paths are such that it enters the origin. So such a critical point is said to be a node. So a critical point which is approached and also entered by each path as t approaches to infinity or t tends to minus infinity is called a node. So a point is approached and also entered by each path as t tends to infinity or as t tends to minus infinity. So that is a node. So let us look at an autonomous system where origin becomes a node. So we will see in detail this problem. Okay. So we have the system dx by dt equal to x and dy by dt equal to minus x plus 2y. Now when you solve for the equation, so you can see that the only critical point will be, so when you take the condition f equal to 0, g equal to 0, so the only point, critical point will be 0, 0. Now upon solving for the equation, you will get the general solution to be x equal to c1 e raised to t and y equal to c2 e raised to t, c1 e raised to t plus c2 e raised to 2t. ഇനി നമുക്ക് ഈ ഓട്ടോണമസ് സിസ്റ്റത്തിന് നമ്മൾ എങ്ങനെയാണ് പാത്ത്, അതായത് എങ്ങനെയാണ് ഒറിജിൻ നോഡ് ആവുന്നതെന്ന് നമുക്ക് നോക്കാം. സോ യു ഹാവ് ദിസ് ടു ബി ദ ജനറൽ സൊല്യൂഷൻ. X equal to c1 e raised to t and y equal to c1 e raised to t plus c2 e raised to t. Now if we take c1 equal to 0, c1 0 ആണെങ്കിൽ we will be getting x equal to 0 and y equal to c2 e raised to 2t. So if c1 is 0, then we will be getting x equal to 0 and y equal to c2 e raised to 2t. And now c2 can be positive or negative. In x 0 and x 0 means that is on the y axis. അപ്പോൾ നമുക്ക് y ആക്സിസിലെ പോയിന്റ്സ് ആണ് കിട്ടുന്നത്. ഇനി c2നെ ഡിപ്പെൻഡ് ചെയ്ത് e raised to dt എപ്പോഴും പോസിറ്റീവ് ആയിരിക്കും. സോ ഡിപ്പെൻഡിങ് ഓൺ c2 you can get positive or negative values for y. So therefore the paths will be along the y-axis. So we will be getting two half lines. So one is the positive y-axis and one is the negative y-axis. അപ്പോൾ നമ്മുടെ സൊല്യൂഷൻ കർവിനകത്ത് അല്ലെങ്കിൽ നമ്മുടെ y-axis നമ്മുടെ ഒരു പാത്താണ്. ഓക്കെ. Now let us take second condition, second case where c2 is 0. ഇനി c2 0 ആകുമ്പോൾ നമുക്ക് എന്താ കിട്ടുന്നത്? x equal to c1 e raised to t വരും, y equal to c1 e raised to t. c2 0 ആകുമ്പോൾ എക്സും c1 e raised to t ആണ്, yയും c1 e raised to t ആണ്, അതായത് രണ്ട് ഈക്വൽ ആണ്. സോ വി ഹാവ് x equal to y equal to c1 e raised to t. Again you know that e raised to t is always greater than 0. Now there are two cases for c1. c1 can be positive or negative. ഇനി c1 പോസിറ്റീവ് ആകുമ്പോൾ അപ്പോൾ x equal to y means that is this line. So when c1 is positive, so we will be getting this portion of the line, and when c1 is negative, we will be getting this portion of the line. So the paths corresponding to c2 equal to 0 will be the two positive